Hello everyone. So now we'll discuss about electrochemistry, the further part of electrochemistry. In the previous lecture, in the previous session, we have discussed about electrode potential. What is the exact meaning of electrode potential? So now we'll discuss about electropotential, standard electropotential, and cell potential. So now first, I will recall what is electrode potential. The electrode potential is nothing but at equilibrium. If I consider a cell at equilibrium, half cell at equilibrium, the potential develops between electrode and electrolyte. The potential develops between electrode and electrolyte is known as electrode potential. That is called as electrode potential. And we know about electropotential. Then what will be the standard electrode potential? So here the standard electrode potential is nothing but it is an electrode potential when the concentration of electrolyte is equals to unity. If the concentration of this electrolyte becomes equal to unity. Unity means what? It may be 1 mole per dm cube or it may be 1 mole per liter. When the concentration of electrolyte becomes 1 mole per dm cube or 1 mole per liter, then the potential develops between the electrode and the electrolyte is called as standard electrode potential. Okay, so here this is our half cell. In this half cell, this zinc electrode has got some standard electrode potential as well as electrode potential. Likewise, the copper electrode also has got some electrode potential. So here, this zinc electrode is negative electrode with respect to solution. With respect to electrolyte, the zinc electrode is negatively charged. And in the same manner, with respect to this electrolyte, this copper electrode is positively charged. So about this, I have explained in my previous session. So now here zinc is negative electrode and the copper is a positive electrode. So there is a difference between the potential of this electrode and as well as this electrode. So now let us define cell potential. The cell potential is nothing but the potential difference. It is the potential difference between two electrodes of a galvanic cell. So this is our galvanic cell. The potential difference between the two electrodes of a galvanic cell is called as cell potential. The potential difference between this cell and this cell is called as cell potential. Simply, see here, the potential difference between this electrode and electrolyte is called as cell potential. In the same manner, the potential difference between these two electrode potential is nothing but cell potential. Simply, the potential difference between two electrodes of a galvanic cell is called as cell potential. Nodili ee electrode ಮತ್ತು electrolyte ಏನಾಗುತ್ತೆ ಅಂದ್ರೆ ಅವೆರಡರ ನಡುವೆ ಏನಾಗುತ್ತೆ ಅಂದ್ರೆ potential difference potential ಏನಾಗುತ್ತೆ ಡೆವಲಪ್ ಆಗುತ್ತೆ. ಸೊ ಆ potential ಡೆವಲಪ್ ಆಗೋ potential ಏನು ಕರೀತೀವಿ ಅಂದ್ರೆ ನಾವು electrode potential ಅಂತ ಕರಿತೀವಿ. The potential developed between electrode and electrolyte. So ಇಲ್ಲಿ zinc is negative electrode and copper is positive electrode. ಈ electrode ಒಳಗೆ potential develop ಆಗುತ್ತಾ, ಈ electrode ಅಲ್ಲಿ potential develop ಆಗುತ್ತೆ, ಹೌದಾ? So ಇವೆರಡು potential difference ಏನು ಕರಿತೀವಿ ಅಂದ್ರೆ ನಾವು we call it as cell potential. I hope you have understood. So now see here, EMF is nothing but electromotive force. So it is nothing but it is also cell potential. It is a type of cell potential. So here the cell potential of the cell is called as electromotive force. The cell potential is also called as electromotive force, but there is a condition. The condition is nothing but when no current is drawn from the cell. So if the current is not drawn through the cell, then that potential is called as EMF, electromotive force. So EMF or cell potential both are same. These two are identical or similar. The EMF, just the difference is the cell potential. We can measure cell potential when the cell is switched on. The EMF is determined when no current is drawn through the cell. If there is no current in the cell, now we can measure that potential difference is EMF. if there is a flow of current in the cell, now that can be calculated or measured as cell potential. So this is about electrode potential, standard electrode potential and cell potential. And remember, to calculate cell potential or EMF, we have got a formula, that is E cell. E cell is nothing but it is EMF of the cell or cell potential of the cell. E cell is nothing but it is EMF of the cell or cell potential of the cell. Both are equal. E cell is equals to electrode potential of right electrode minus electrode potential of left electrode. So E right minus E left. So E right indicates this is electrode potential of right electrode minus electrode potential of left electrode. So here in this arrangement, E cell, for this E cell can be calculated as E cell is equal to, see here, so this is our zinc in contact, zinc with copper. Zinc with copper means which electrode, which cell it is? Daniell cell. It is an example of Daniell cell. So for this Daniell cell, let us calculate E cell. E cell for Daniell cell becomes electrode potential of right electrode. E right which is right? Copper electrode. Copper electrode minus E left zinc electrode. See here, at the right side we have got copper, at the left side we have got zinc. So E cell is equals to electrode potential of copper minus electrode potential of zinc. And in the previous session or in the first session, we have discussed about according to IUPAC nomenclature or IUPAC recommendations, we have to consider standard reduction potential as electrode potential. So for each and every cell there exists two potential. The first one is reduction potential and oxidation potential. So we have to consider standard reduction potential as electrode potential. So because of that reason, I will take it as reduction potential Cu2 plus bar Cu, Zn2 plus bar Zn. So this is the formula to calculate E cell of this Daniell cell. E cell is equals to electrode potential of right side cell, right side electrode minus electrode potential of left side electrode. So this is about electrode potential, standard electrode potential, cell potential and EMF. I hope all of you understood. Thank you.